This video is an introduction to logarithms. So what is a logarithm? A logarithm is just another way of writing exponents. So we have logarithmic form, which is read as log base b of a equals x. That's how you read it. And then we can actually rewrite it in exponential form. So if you keep the log on the left-hand side, you start at your base, you hit your x, and then you land at your a. And so the exponential form is b to the x is equal to a. So it follows the loop-de-loop. A common logarithm, so it's a log with base 10 is called a common logarithm and can be written without a base. So if you have log base 10 of x, you can write that as log of x. There is no base in a log base 10. We can actually convert from logarithmic form to exponential form. Just make sure that your log is always on the left-hand side. So we will do the loop-de-loop. We'll start at your base, hit the 2, land at the 9. This can be rewritten as 3 to the second equals 9, which makes sense because 3 squared does equal 9. We can do the same thing with number 2. Follow the loop-de-loop. 2 to the 4th is equal to 16, which is true. Number 3 gets a little weird, but you still follow your loop-de-loop, so 4 to the negative second equals 1 over 16. Now I want to explain this one just a little bit. Anytime you have a negative exponent, it drops to the denominator. So if I have 4 to the negative second, that's really 1 over 4 squared. Well, 4 squared is in fact 16. So this does equal 1 over 16. And number 4 is also a little weird, so we're going to start at the 9, hit the fraction, land at the 27. So 9 to the 3 halves is equal to 27. Another property of exponents says that anytime you have a fraction as an exponent, that is your radical. So the denominator will tell you your index, the numerator will tell you the power inside. So this is the square root of 9 cubed equals 27. Well, 9 cubed is 729. Just continue over here. So we have the square root of 729, which that is a perfect square of 27. So this is a way to convert from logarithmic form to exponential. In the same way, we can go from exponential to logarithmic. You just want to, again, make sure that your exponent now is on the left-hand side. And we are still going to do a loop. Okay, so this will be log base 14 of 196 is equal to 2. That's how you would write it. Do the same thing with number 2. Log base 36 of 6 is equal to 1/2. Number 3, log base 2 of 1/8 is equal to -3. And number 4, so log base 8 of 16 is equal to 4/3. We can use exponential form to evaluate logarithms. So your first step is to convert to exponential form, then use your knowledge of exponents to find x. So in number 1, we can have log base 7 of 49 is going to equal x. We don't know what it's going to equal. So we're going to convert to exponential form. So this would be 7 to the x is equal to 49. Well, 7 to what power is equal to 49? Well, if you square 7, you get 49. So that means that x equals 2. So this log is equal to 2. Let's try number 2. If there's no base, it's base 10. Okay, so you can do your loop. 10 to the x is equal to 100. Well, 10 to what power is 100? that would be squared. So x is equal to 2. This log also equals 2. Let's try number 3. So we'll do our loop. 12 to the x is equal to 1. So this one is kind of tricky. 12 to what power is equal to 1? Well, any number to the 0 power is equal to 1. So this is actually a property of a logarithm. So anytime you have log base something of 1, it's going to equal 0. Okay, so in this case, x is going to equal 0 because 12 to the 0 is equal to 1. Let's look at number 4. So we're going to do our loop. 9 to what power is going to equal 1 over 81? Well, anytime you have a fraction, it means that you have a negative exponent. So what we can do is I can say, okay, I need my x to be negative. Actually, that's not right. Okay, it'll still be positive in the denominator. So now think, 9 to what power gives you 81? Well, squared. But since it drops to the denominator, then your x is equal to negative 2. 9 to the negative second is equal to 1 over 81. Now let's talk about change of base. So some logs are not as easy to evaluate and will require a change of base. So the formula for your change of base, if you have log base b of a, it will be log of a divided by log of b. This can actually be evaluated in your calculator. So if you look at your calculator to the left-hand side, you do have a log button. That means your calculator will only do log base 10. So for example, if you have log base 16 of 64, if you don't know what that is right off the bat, you can do your change of base. So that would be log of 64 divided by log of 16. We have to follow the formula. And if you punch that into your calculator, you're going to get 1.5. Same thing with number 2. If we have log base 10 of 294, well, number 1, you can already punch that into your calculator. But if you wanted to do the change of base, you could do log of 294 divided by log of 10, because your base here is 10. If you punch that into your calculator, you are going to get 2.468. For number 3, log base 6 of 1 over 36. So you can do log of 1 over 36, and whenever you punch that into your calculator, make sure that it is in parentheses, divided by log of 6. So whenever you evaluate that, you are going to get negative 2. So that's how you use your change of base formula.